Welcome to this episode of Topics in Neuroscience. Today's subject is haptic perception. What is haptic perception? Well, that's a good question. Let's answer it. It is the active touch process by which we are able to perceive and then subsequently identify objects based on their shapes and other properties, such as hardness. But we also do this through integrating tactile, proprioceptive, and thermoreceptive information. Tactile information is received from mechanoreceptors in our skin, like the ones you see here. And these receptors give information related to shapes, edges, corners, curvature, textures, and other surface features. Then, from skin stretch receptors and muscle spindle fibers, proprioceptive information allows us to obtain shape-related info by sensing our hand position and conformation on an object, as well as telling us about weight information and how much force is being applied on our limbs. And then thermoreception helps to provide further material property info based on temperature. Now we need to go into a little bit more detail about mechanoreceptors, so we're going to start off with the SA1, or Merkel cell, for its specialized ending. These receptor cells are usually found in the upper dermis, are relatively dense in distribution, especially in your fingertips, and they're most responsive to indentation by edges, curves, and textures, and they're useful for perceiving pattern, texture, and shape. The next slow adapting cell we'll talk about is SA2. They're found in the dermis, relatively sparse in distribution, respond best to stretch, and perceive skin stretch and hand conformation as a function. And the question mark by Ruffini is just because they're still not sure whether there's evidence for these cells yet. Now we move to fast adapting. Our first one we'll talk about is the FA1 cell, also known as the Messner corpuscle after its specialized ending. These are in the upper dermis, are relatively dense, especially in your fingertips, react best to motion and low frequency vibration, and function in perceiving slip and maintaining grip control. Finally, move to our last fast adapting cell, also called the Pacinian corpuscle. These are found in the lower dermis, are relatively sparse, and respond best to high frequency vibration. Their function is for perceiving fine textures through transmitted vibrations. Now let's get a quick overview, or a rewind. This infographic is just serving to show you where the receptors are located, whether they be near the surface of the skin or deep in the skin. And also remember that all of them work together and they integrate to help you do things like determine what an object is with your eyes closed, or be able to pick your keys out of your pocket without looking. Now that we've covered that, let's move on to haptic technology and integration. We'll look at it through gaming, medical, business, automotive, and many more avenues. But first, let's start with the demonstration. What haptics is, or haptic technology is they use ultrasonic sensors, and by changing the frequencies and using an interface like the one you see in the picture, you're able to manipulate the sound waves to do things like you're about to see here. What would be referred to as mid-ear haptic technology or interface, this is a haptomine, and as you can see, they're not touching any buttons. All they're doing is using that interface and that same kind of system that I talked about, manipulation of the sound waves with a software interface, to be able to interact with that, even though there's no hard keys. This brain surgeon is using a more traditional haptic technology where it's just pressure feedback and vibration feedback to let him know what he's doing or what mistakes he's making. And this is a patent idea for an augmented reality virtual reality simulator suite for surgeons, clip and aneurysms. This clip and a lot of the following are just conceptual visualizations of what haptic technology could be in the future, but this here you see it being used in a business sense, here in entertainment, here at home. The applications are endless for haptics, and even safer. See, usually in a car you have to look down at the console to see things. You count on your visual system. But with haptic-based technology, you can just feel it, and you don't have to look. This suit is a prime example for gaming. It allows you to experience wind and all kinds of different sensations. If the suit is out of your price range, though, this is a non-profit solution. I Feel Pixel allows you to buy an app that lets you use haptic devices to interface with your computer and other compatible devices for a richer sensory experience.